all, this is Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. We are in the chapter of limits and in today's video we will look at trigonometric limits. How to solve the limits which contains trigonometric functions. Very important topic when it comes to the chapter of limits. Okay now. So in this chapter first we will see how to prove these limits. Limit x approaches 0, sin x by x is equal to 1. Limit x approaches 0, tan x by x is equal to 1 and remaining. We will see how to prove these limits. Okay now, and particularly look at this. Students might get confused in these kind of limits. Limit x approaches 0, step of sin x by x is equal to what? Limit x approaches 0, step of 100 into sin x by x is equal to what? So we will discuss all this in today's video. Okay, let us start the video. First we will start with the proof of limit x approaches 0, sin x by x using expansions. Okay, let us prove that limit x approaches 0, sin x by x is equal to 1 using the left hand limit and right hand limit. Okay, now observe that using left hand limit and also right hand limit. First, if I go for LHL, the left hand limit x approaches 0 minus, okay, what is sin x expansion, dear students? X minus x cube by 3 factorial plus x power 5 by 5 factorial and so on with common denominator x na. So I can separate the common denominator x for all the terms. If that is the case, you will get limit x approaches 0 minus the common denominator. If you separate, you will get 1 minus x square by 3 factorial plus x power 4 by 5 factorial and so on. Next, we already know that if x approaches 0 minus, it means that x is equal to 0 minus h, where h approaches 0, So let me replace x with minus h in this function. So limit h approaches 0, 1 minus, instead of x I am going to take minus h whole square is h square only by 3 factorial plus minus h whole power 4 is h power 4 divided by 5 factorial and so on. Observe one thing, you have to understand that from 1 you are subtracting something. The next term will be minus and so on. From 1 you are subtracting something, correct or not? So 1 minus of h square by 3 factorial minus h power 4 by 5 factorial and so on. H value you know already, 0.000000 and so on. So from 1 you are subtracting almost infinitely smaller number. So your answer will be 1 minus. 1 minus means what? 0.99999 and so on, correct or not? So from 1 you are subtracting infinitely smaller number. So your answer is infinitely closer to 1 minus. Okay, now it approaches 1. From which side? From left side. But generally we will not take 1 minus. We will generally write it as 1. But why should I remember this 1 minus means? I will say. Particularly remember, dear students, from LHL what we have got? The left hand limit of this function. In LHL we have got 1 minus. Of course it is 1 only, but remember it is 1 minus, just less than 1. Okay now. Next, in RHL, I am not doing it separately. Here itself we can do now. In RHL, right hand limit. X approaches 0 plus, same function. X approaches 0 plus, same function. Here we will write what? X is equal to 0 plus h, correct or not? Where h is approaching 0. 1 minus h square, x means h, x is equal to h na, h square, h power 4. The same thing will come again. Again you will get the same thing. That means what? Even RHL is also same answer. 1 minus of something, infinitely smaller number. So RHL is also 1 minus, particularly 1. So remember, left hand limit is approaching 1 from the left side and right hand limit is also approaching 1 from the left side. Okay now, anyhow, left hand limit is equal to right hand limit. LHL is equal to RHL, both are equal to 1, correct or not? Since left hand limit is equal to right hand limit, we can say that limit x approaches 0, sin x by x is equal to 1. Limit x approaches 0, sin x by x is equal to 1. You can also prove the same limit using L'Hospital's rule. Let us also see it once. I am proving the same thing using L'Hospital's rule now. What is L'Hospital's rule? If you take the left hand side, LHS, limit x approaches 0, sin x by x And when I substitute x as 0 in the function, sin 0 is 0 divided by x is also 0. So remember, we can use L'Hospital's rule only when the function is taking 0 by 0 form or infinity by infinity form. Okay, and moreover, the derivative of the numerator also exists. The derivative of denominator also exists when x is approaching 1. So I'm going to take L'Hospital's rule. By L'Hospital's rule, this is equal to what? Numerator derivative, which is cos x, divided by denominator derivative. In upcoming videos, I'll certainly discuss what is L'Hospital's rule. Okay, now, anyhow, you already might have heard about it. Numerator derivative divided by denominator derivative. Okay, now you can substitute x as 0, you'll get cos 0, which is equal to 1. See, I got the same answer using L'Hospital's rule, correct or not? So I have given you two different proofs for this. Now, here is the question. What is limit x approaches 0, step of sin x by x? Step of sin x by x. Very simple, you can take limit inside. So step of limit x approaches 0, sin x by x, correct? And what students will do after this step? Sir, this value is 1, sir, inside. So step of 1 is equal to 1. That is what they will say. But this is not correct answer. What is the mistake here? I'll let you know. I already told you in LHL and RHL that limit x approaches 0, sin x by x is actually 1 minus. It is not exactly 1, it is 1 minus. 1 minus means 0.9999 and so on. And what is step of 0.9999 and so on? The step of 0.9999 and so on is equal to 0. The actual answer is 0. It is not equal to 1. Remember this. You might think that the answer is 1, but the answer is not 1. Why the answer is not 1? Because this function's original limiting function is 1 minus. It is not exactly 1. The limiting value of this function is 1 minus. That means 0.9999 and so on. So its step value will be equal to 0. Okay, na? So remember this. Okay, we'll go with the next proof. Limit x approaches 0, tan x by x is equal to 1. So first I will prove this using LHL and RHL. So first of all, let me take the left hand limit. Limit x approaches 0 minus tan x by x, and tan x expansion. What is tan x expansion, dear students? You should have by hearted it properly. X plus x cube by 3 plus 2 by 15 into x power 5 plus and so on with common denominator x. Okay. So observe, all are positive. It is not plus minus plus. All are positive. Please observe this. Okay. And odd powers of x only. So common denominator x, if you separate, limit x approaches 0 minus 1 plus this divided by this is x square by 3 plus this divided by this is 2 by 15 into x power 4 plus and so on. Now since you are finding left hand limit, x approaches 0 minus means x is equal to 0 minus h, where h approaches 0, correct or not? Instead of x you can substitute minus h. X is equal to minus h. If you substitute, what will you get, dear students? Limit h approaches 0, 1 plus minus h whole square is h square only, na? By 3 plus 2 by 15 into minus h whole power 4 is h power 4 only, na? Plus and so on. So and h approaches 0, you can substitute h value as 0. So what will you get? 1 plus 0 plus 0 plus and so on. So the answer is 1. But observe one thing, the answer is not exactly 1. It is 1 plus this value is 0.00000 and so on. Maybe 10 power minus 20 or 10 power minus 200, whatever it is. The original answer is not 1. It is 1 plus 0.000 something, which means the original answer is 1 plus. Remember this. While finding limit x approaches 0, step of tan x by x, we will use this value. Okay, na? So left hand limit is 1 plus, but we will take it as 1. Okay. Now, what about RHL now? Here itself we can find RHL, right? Same way, the right hand limit is x approaches 0 plus tan x. Same function. Here 0 plus means we will write x is equal to 0 plus h. Same function. And instead of x, we will substitute plus h square, h power 4 and so on. And finally, the same answer will come. Okay, na? Same answer only will come here. So RHL is also 1 plus only. LHL is 1 plus. RHL is also 1 plus, but I'll write it as 1. So left hand limit is equal to right hand limit, both are equal to 1. Therefore, what is the conclusion? Limit x approaches 0, tan x by x is equal to 1. And original answer is 1 plus. Remember, it is 1 point something. 1 plus. Okay, na? 1 plus. But we will write it as 1 only. Limit x approaches 0, tan x by x is 1. But if needed, you should take it as 1 plus. Next, let us also prove the same thing using the previous result, sin x by x, and also L'Hospital's rule. 2 more proofs are there. Let us also learn that. It's very important to know these things. See here, the second way of proving this is very simple. Limit x approaches 0, tan x I'll write sin x divided by cos x. Okay, tan x I'll write sin x by cos x. What is it? Here by sin x is there in the denominator, and this is of course 1 only. I just wrote tan x as sin x by cos x. Okay, and limit can be given for both the functions. Limit x approaches 0, sin x by x is 1 into limit x approaches 0, 1 by cos x. You can substitute x value as 0 here. Cos 0 is 1, correct or not? So 1 by cos 1. The answer is 1. You can also prove it like this. Is it easy or not? And at the same time, you can also use L'Hospital's rule. Limit x approaches 0, because the function is taking 0 by 0 form when you substitute x as 0. Correct or not? If you write tan x by x, you are getting 0 by 0 form. If I go for direct substitution, then using L'Hospital's rule, the numerator derivative is secant square x and denominator derivative is 1. Now if you substitute x as 0, secant square 0, that is also 1. So I can prove it using expansions. I can prove it like this using this, and I can also prove it using L'Hospital's rule. Okay, now there are many proofs like this. Okay, now let us see one more question here. Now what is limit x approaches 0, step of tan x by x? Okay, the answer, what is it, man? Limit x, step of, you can take limit inside the step. Step of limit x approaches 0, tan x by x. Go with the topic of rules of limits, rules of finding limits. There you can find all this. Now what generally students will do? What kind of mistake can we expect from them? Step of this limit they'll write 1, and step of 1 they'll write 1, and this is wrong answer. Why means, dears? Oh, not wrong answer. Somehow by luck here you are correct only. Why means limit x approaches 0, tan x by x is what? It is not 1 minus, it is 1 plus. So step of 1 plus is equal to 1 only. Okay, na? So this is what? Limit x approaches 0, step of tan x by x is 1, but limit x approaches 0, step of sin x by x, how much we got? There we got 0, here we have got 1 as the answer. Okay, next, an important note to remember. So note number 1. What is note number 1, dear students? Limit x approaches a. When x is approaching a number a, if f of x is approaching 0, then we can say that sin f of x divided by f of x is 1. Why? Because you can replace f of x with y. Okay, now then what happens to this? Limit y approaches 0, sin y divided by y. How much? 1 only, na? That's what I have written here. When x is approaching a number a, if f of x is approaching 0, then sin f of x divided by f of x is 1. Let us see simple examples. Example, limit x approaches 0, sin x square divided by x square. What is the answer, dear students? 1. Because when x is approaching 0, this is f of x now. X square is also approaching 0. So therefore the answer is 1. Another example, limit x approaches pi by 4, sin of sin x minus cos x divided by pi by 4 minus x. Observe, what is it? Limit x approaches pi by 4, sin of sin x minus cos x divided by pi by 4 minus x. Or let me take it as sin x minus cos x only. Later in examples we will see how to simplify these kind of questions. When x is approaching pi by 4, this is f of x. And f of x is taking what value? When I substitute x as pi by 4. Sin pi by 4 minus cos pi by 4. 1 by root 2 minus 1 by root 2, it is approaching 0, correct or not? Sin x minus cos x is approaching 0. When x is approaching pi by 4, sin x minus cos x is approaching 0. This is our f of x. So what happens to the question? It becomes sin f of x divided by f of x. When x is approaching pi by 4, f of x is approaching 0. So therefore, what is the value of sin f of x by f of x? It is equal to 1. So when x is approaching pi by 4, f of x, this is approaching 0 na. So sin f of x divided by f of x will be equal to 1. This is one of the most important properties which I will be using to solve trigonometric limits. Keep this in mind. Okay na. So same way, when x approaches a, if f of x approaches 0, sin f of x by f of x is 1. We can also apply the same thing for tan also, correct or not? So when x is approaching a, if f of x is approaching 0, then tan f of x by x is also approaching what number? 1. Just like sin, tan also approaches 1. A simple example if you want. Limit x approaches 0, tan of tan x divided by tan x. What is it? When x is approaching 0, who is f of x here? Tan x. When x is approaching 0, tan x is also approaching 0. Because tan 0 is 0 na? When x is approaching 0, tan x is also approaching 0. So this is f of x. This is f of x. So it is in the form of tan f of x divided by f of x. Correct? Which is equal to 1. Okay, remember this. This is very, very important note that we will be using while solving the questions. Okay, next. Second note, note number 2. What is note number 2? Limit x approaches 0, sin kx divided by x is equal to k. Limit x approaches 0, tan kx by x is equal to k. Sir, how can we prove it, sir? Very simple. So what I'll do is, when x is approaching 0, this kx is there na, kx is also approaching 0. So it is in the form of sin f of x. Then in denominator also I want f of x. So multiply the denominator with k and the numerator with k. Then limit x approaches 0, f of x is also approaching 0, sin f of x divided by f of x, this value is 1. So 1 into k will be equal to k. So therefore, dear students, what can we say? Therefore we can say that limit x approaches 0, sin kx divided by x is directly equal to k. Example, limit x approaches 0, sin 3x divided by x, it is equal to 3. And look at this example. Limit x approaches 0, sin x degrees divided by x. It is not x, it is x degrees. Can I say that the answer is 1? The answer is not 1. Why the answer is not 1? Because x coefficient is 1 degree. X degrees means what, dear students? 1 degree into x. So what is that k? K is 1 degree. But generally you will not find the answer as 1 degree. So once again I am repeating. Limit x approaches 0, sin kx divided by x, where the k value is 1 degree. Okay na? So therefore the answer is k, which is 1 degree. But generally you will not find this option. This 1 degree will be taken as pi by 180 radians. You will find this option. So remember, dear students, limit x approaches 0, sin x degrees divided by x is not 1. It is 1 degree. 1 degree means pi radians by 180. Pi by 180 radians. So these are some few examples. Same way, dear students, you prove this. Limit x approaches 0, tan kx by x is equal to k. And how can we use it? A simple use. Limit x approaches 0, tan 11x divided by x will be equal to how much? Obviously 11. Okay, next we'll go with the next one. Generally the students who are doing limits na, they will see limit x approaches 0, sin x by x equal to 1 and tan x by x is equal to 1. But they will not see this one. Limit x approaches 0, cos x by x. They will not see this. How many of you have got this doubt? What about limit x approaches 0, cos x by x is equal to? If you have got the doubt, how many of you know the answer? How many of you have tried it? Let us see what is the answer using expansions. What I'm going to do, let us use expansions to see what is the answer. What is the answer? Let us see. So LHL if I take, or let me take the left hand side, limit x approaches 0, the numerator expansion is 1 minus x square by 2 factorial plus x power 4 by 4 factorial and so on, with what denominator? X. X can be separated, the common denominator can be separated. Limit x approaches 0, okay na, 1 divided by x minus x square divided by x. So this is x square by 2 factorial by x na, you get x by 2 factorial, then what, plus x cube by 4 factorial and so on. Now let me divide it into two limits. What is the first limit? The left hand limit. Here x approaches 0 minus, x approaches 0 minus, so we will substitute x is equal to 0 minus h, which means minus h. And in right hand limit, x approaches 0 plus, and we will substitute x as what? Plus h. First left hand limit if I substitute. In left hand limit, when I substitute x as minus h, what do we get, dear students? 1 divided by minus h, that means minus 1 by h. Okay, minus of minus h, which means plus h by 2 factorial, and then minus h whole cube by 4 factorial is minus h cube by 4 factorial and so on, with limit h approaches 0. Now when h is approaching 0, if I substitute h as 0, we are getting minus 1 by 0. That means we are getting minus infinity. The remaining terms will become 0, but minus 1 by 0 na, left hand limit is what, dear students? Minus infinity. And what about right hand limit? If I try to find RHL, what will you get? In the same function. So in RHL, x is equal to plus h, right? If I substitute x as plus h, what will I get? 1 by h minus h by 2 factorial plus h cube by 4 factorial and so on. Now if I substitute h as 0, limit h approaches 0 only na. When I substitute h as 0, I am getting 1 by 0, so which is plus infinity, and remaining terms will become 0. 0 by 2 factorial, 0 cube by 4 factorial, all of them will become 0. So and the RHL is plus infinity. Observe, LHL is minus infinity and RHL is plus infinity. So what is the conclusion, dear students? Limit x approaches 0, cos x by x. What about cos x by x? The answer is does not exist. The answer is does not exist. Some of you might have thought, sir, when I do the substitution, I'll get cos 0, which is 1 divided by 0, 1 by 0 infinity form. So I thought the answer is plus infinity. You might have thought correct or not. So but limit x approaches 0, cos x by x does not exist. That's the reason why we will not find this particular limit while solving trigonometric limits. So what is the answer, dear students? Here it is does not exist. Okay, fine. We'll go with next limits. Next, let us see the proof of limit x approaches 0, sin inverse x by x, which is 1, and limit x approaches 0, tan inverse x by x, which is 1. Okay na? So to solve this, dear students, I am not going to use the expansions of sin inverse x because you do not remember it. You may not know it. So what I will do is, I will let sin inverse x is equal to y. Okay na? Then we can say that x is equal to sin y, but actually what happens means we will apply sin on both sides. So I will apply sin on both sides. Sin of sin inverse x equal to sin y. And observe, x is approaching 0. X is approaching 0 na. So x is between minus 1 and 1 only. We can ignore sin and sin inverse. So you will get x is equal to sin y. X is equal to sin y. When x is approaching 0, sin y is approaching 0. Then y is also approaching 0. Correct or not? So what happens to the question here? Limit. Instead of writing x approaches 0, I will write y approaches 0. And instead of sin inverse x, I will write y. And instead of x, I will write sin y. So what is this, dear students? It is a reciprocal of what you learned. What is it? Limit y approaches 0, 1 divided by sin y by y. So we know that limit y approaches 0, sin y by y is 1. Correct or not? This is 1. So 1 divided by 1 is equal to 1. So therefore the answer is 1. Similarly, can you prove this? You can prove this. Okay, now that limit x approaches 0, tan inverse x by x is equal to 1. You can prove this. And next, a small note here also. So what is that small note? Limit x approaches a. When x is approaching a, if f of x is approaching 0, then sine inverse f of x by f of x. The limiting value of this function is also 1. When x is approaching a, if f of x is approaching 0, then sine inverse of f of x by f of x is also equal to 1. Okay, now similarly, limit x approaches a. If f of x is approaching 0, then tan inverse f of x by f of x is also equal to 1. Okay, now if you want a simple example, what is limit x approaches a? Sine inverse of x minus a divided by x minus a. When x is approaching a, this is your f of x, correct or not? X minus a is approaching 0 only, na? So this is approaching 0. Therefore the answer is how much? 1, because it is in the form of sine inverse f of x by f of x. So the answer is 1. Okay, we'll go with the next one. So let us start solving some basic questions on this topic now. An important result to remember in limits, what does it means? Limit x approaches 0, 1 minus cos 2x by x square. 1 minus cos 2x by x square, its value will be 2, and limit x approaches 0, 1 minus cos x divided by x square, its value will be 1 by 2. Okay, now these two we must remember, particularly this one, because we'll be using it directly while solving the problems. So let us see the proof of it. Here if I want the proof, the left hand side LHS is equal to limit x approaches 0 and 1 minus cos 2x. In trigonometry, what is the formula of 1 minus cos 2x? 2 sine square x whole divided by x square. So you can take 2 outside, limit x approaches 0. This is sine square x by x square, and I can write as sine x by x whole square. So 2 into limit x approaches 0 can be taken inside the square. Limit x approaches 0, sin x by x is 1 with square. So 2 into 1 square. So that's why limit x approaches 0, 1 minus cos 2x by x square is equal to 1. Now what about this one? Again I will take LHS. Limit x approaches 0, 1 minus cos x is 2 sin square x by 2. And here we have x square. Okay, now you can take 2 outside. It is limit x approaches 0, sin x by 2 divided by x whole square. Please observe one thing, dear students. This is in the form of sin kx by x. This is in the form of sin kx by x. What is k value here? X coefficient. K value 1 by 2. So 2 into, we know that limit x approaches 0, sin kx by x is k. And what is that k here? 1 by 2. And observe 1 by 2 whole square. So you will get how much? 2 into 1 by 4. The answer is 1 by 2. So what result did I use here? Limit x approaches 0, sin kx by x is equal to k. That k value is 1 by 2. Okay, na? So these two are very, very important. We will use it directly while solving the problems. Particularly this one. Do remember, limit x approaches 0, 1 minus cos x by x square is equal to 1 by 2. Particularly remember this. Okay. Let us see some basic problems on these models. The first one, limit x approaches 0, sin 11x by sin 5x. What is the answer? The answer is obviously 11 by 5. But why? Divide the numerator and denominator with x. Limit x approaches 0, sin 11x by x divided by sin 5x by x. So limit x approaches 0, the numerator is in the form of sin kx by x na, and its value is k, and denominator is also in the form of sin kx by x na, and its value is k. So 11 by 5. Numerator will give you 11 and denominator will give you 5. So answer is 11 by 5. So we have more examples to follow, very, very important examples, and we will see all those examples in a different video. So I hope you understood this concept, very important concept. So if you understood it, do like the video, share it to your friends. This is M. Sandeep Kumar. See you all in the next video.